Alright, so today we're going to look at AP Stats question 3 from the 2015 exam. A shopping mall has 3 ATMs because the machines receive heavy use. They sometimes stop working and need to be repaired. Let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected day. The table shows the probability distribution of x. Okay, so A, what is the probability that at least one ATM is working when the mall opens? So the notation P x greater than or equal to 1. This is the probability that the random variable x, which represents the number of ATMs that are working, is greater than or equal to 1, or at least 1. This is what greater than or equal to means. So I can state that this is also equal to 1 minus the probability that random variable x is less than 1. Well, this occurs only once. This occurs right here. 0 is less than 1, therefore the probability that x is less than 1 is 0.15. So 1 minus 0.15 is equal to 0.85. So that's our answer for part A. Right, P x greater than or equal to 1 is equal to 0.85. Okay, now let's look at part B. What is the expected value of the number of ATMs that are working when the mall opens? Well, if you take a look at your reference table, you'll find the formula E of x is equal to the sum of, this is sigma, the sum of the individual values times their individual probabilities. So this is simply equal to 0 times 0.15 plus 1 times 0.21 plus 2 times 0.4 plus 3 times 0.24. And this summation is equal to 1.73. That's we're going to write E of x is equal to 1.73. Alright, now, oops, get that out of the way. So, now the next part is part C. What is the probability that all 3 ATMs are working when the mall opens, given that at least one ATM is working? Okay, well, we can write a statement. We can write the probability, let me just do this. This is A, this is B, this is C. The probability that x is equal to 3 given x is at least 1. Well, this is just simply equal to the probability. See, this notation, this straight dash line is basically a fraction. So like this, probability that x is equal to 3 divided by the probability x is greater than or equal to 1. Well, this value, we actually know this value. This value is simply 0.24. So for example, 0 means that there are 0 ATMs working when the mall opens. 1 ATM working when the mall opens. 2, so on and so forth. So the probability that x is equal to exactly 3 is just 0.24. So I can write 0.24. And we calculated this value right up here, just 0.85. Often the exam does that. It has you calculate something that you're gonna need in the future. So if you get this one wrong, you're most likely still gonna get credit for this, as long as you show the proper notation and all the appropriate work. And this is equal to 0.2824. So over here, you should write probability x equal to 3 given x greater than or equal to 1 is equal to 0.2, make that clear, puts a decimal, 0.824. Okay, nice. So now question D is saying, given that at least one ATM is working when the mall opens, so there's something key about this. Given that at least one ATM is working when the mall opens, at least one. So no matter what, one ATM must be working with the expected value of the number of ATMs that are working be less than, equal to, or greater than the expected value from part B. Well, let's see. If no matter what, one ATM must be working, this doesn't exist. Because now at least one ATM must be working when the mall opens. That means that this probability value doesn't exist anymore. And as you know, the probability values in a set must all sum to 1. So I've checked it, all these values sum to 1. That means that if this is eliminated, if the chance that 0 ATMs are working when the mall opens is eliminated, all of these values will go up. So when you go ahead and do your weighted sum, you're going to get a larger number. Of course, you don't know what these probabilities will now be, but they will be greater than they are now. So you can state that, given that at least, okay, you can state that since the probability of 0 ATMs working when the mall is opened is eliminated, and the individual probabilities, I'm just going to say P, probabilities must sum to 1, getting rid of 0 means that the individual probabilities of the other values will increase. So according to the expected value equation, the new value will be greater than the value determined in B. Alright, and that's getting full credit for this question.